All right, so we are going to do section 6.1.5 today. So just as a heads up, I will not be here for the rest of the week. So all the lessons will be on video, and then you'll still have your team test. And then all the homework will still be due the next day, and answers, keys, and all that will still be online. So 615 is about converses. So this is a little bit different than what we've been doing with flowcharts. In first period, you guys will do more flowchart practice tomorrow, and then and then you'll do review for the team test and then the team test the next day. And then in ninth period, you'll do flowcharts practice tomorrow for the first time by yourselves, even though we did it together on Thursday. And then you'll do a review and then the team test. So the team test is pushed back one day. So 641 says, George is working with the diagram below, it's actually to the right, and concludes that AB is parallel to CD. He writes the following conditional statement to justify his reasoning. Remember, a conditional statement is if something, then something. So whatever is in there, it doesn't matter as long as it's if, then. So the conditional statement is if alternate interior angles are equal, then lines are parallel. So then the next part, it says Margaret is working. Let me highlight actually this. Margaret is working with a different diagram shown below. She concludes that x equals y. So it says write conditional statement that justifies her reasoning. So we're going to start with what is true in the picture so far. So we're going to say, because there are parallel lines here, we're going to say if parallel. Then she's saying x equals y, and specifically x and y are alternate interior angles. So we're going to say then alternate interior angles are equal or congruent, or however you want to write that. So then part B, it says, how are George's and Margaret's statements related? How are they different? So there could have been different ways you wrote these sentences, but still kind of getting at the same point of talking about parallel lines and also, and also alternate interiors. So in the first one here, it talks about alternate interior first, but in the second one, they talk about alternate interior second. And then if I switch to a different color and talk about the other piece, when we're talking about parallel lines, it's second, but then in the second sentence, it's first. So it's like switching the information in relation to the words if and then. So let's write that. It's the same info, but the location has switched. So again, we're not talking about any new stuff. It's just moving where it's been talked about. And you can see that with the color coding. So in the next part, it says conditional statements that have this relationship are called converses. So let's just remind ourselves what that is. If alternate interior angles are equal, then lines are parallel. But then if parallel, then alternate interior angles are equal. What's happening is they're switching. That's called converse. So it says write the converse of the conditional statement. If lines are parallel, then corresponding angles are equal. So we just have to switch the information inside here. So I've got to switch this piece. Oh, I didn't write it all, did I? This piece and this piece. So we're going to switch those, but keep the if and then. So if, and then I'm just copying down the pink part corresponding angles are equal. And then use the then, because that's where I've hit. On my sentence, I'm out of stuff to write. So then, and then I'm taking the orange part, lines are parallel. So this is actually a pretty simple concept, and the idea is you're just switching pieces around. There is a little bit more to talking about it, but that's the gist of it. All you're doing is just switching the sentence. So 642 says, in problem 641, you learn that each conditional statement has a converse. So conditionals are if-then, converse is switching where the if-then information is. Do you think that all converses of true statements are also true? Excuse me. Consider the conditional statement of a familiar theorem. So it's saying if triangles are congruent, then corresponding sides are congruent. So we're going to think about, is this statement true? If I have two congruent triangles, are all the sides going to be congruent? Yes, because all the pieces and parts have to be the same, so we're going to write yes here. Then the next part, it says, write the converse of this conditional statement. Is this converse true? So the converse is switching the info. So if, now the blue part without the then, corresponding sides are congruent, then, and then we're going to go to the pink part because that's what's left here, triangles are congruent. So we wrote that statement. Now we have to decide if this new statement is true. It's talking about, oh, I didn't need that comma there, sorry. Ooh, that got too big. There we go. So if you have corresponding sides congruent in triangles, are the triangles going to be congruent? So that's like looking at a picture like this where I've got 1, 2, and then 3 sides. Sets are equal to each other. Well, that represents side, 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 and is side, side, side congruence a shortcut? Yes, so this statement is also true. We kind of looked at this different, though, than we looked at the first sentence because it's a different situation. So just kind of keep that in mind as we move forward through these questions today. So the next part, it says, now consider another true congruence conjecture. If triangles are congruent, then corresponding angles are congruent. So I'm going to highlight if triangles are congruent. Here we'll use green. Then corresponding angles are congruent. So write its converse and decide if it's true. So we're going to write the switched sentence. So if, and then I'm going to go to green, corresponding angles are congruent. Then, and then I'm going to go to blue because I ran out of stuff to write for green. Triangles are congruent. So now that we've written that sentence, we have to think about, is that always true? And if it isn't, why not? So if I've got two triangles and the angles are always congruent, that means it looks something like this. So I've got just marks to show that they're equal. And then I think about what shortcut would that be from my yellow sheet. That would be angle, angle, angle technically. But angle, angle is the one that we're kind of looking at here. And we know that that is only a similarity condition. That is not a shortcut for triangles being congruent. So no. Although the first sentence that we started with in the problem where it says if you have congruent triangles, then the angles are congruent is true. That's definitely a thing. If I know the triangles are exactly the same shape and size, then the angles will be the same. But just because that's true does not mean that its converse will be true. And that's like the big thing. It can get confusing because the sentences look almost exactly the same. And that's kind of why we're talking about it. It looks exactly the same almost. You're just switching information. But what it really is talking about is two different things here. And that can happen a lot. Where you're talking about two different things and they can be, one can be true and one can be not true. So you just have to be careful when you're reading these sentences because they do look a lot alike, but once you read it and think it through, you'll know what it's supposed to be talking about. So then the next part, it says, write the converse of the conditional statement. If a shape is a rectangle, then the area of the shape is b times h. and then you're going to talk about if that's true. So I want you to take a second to try that on your own, and I'm just going to write the conditional quietly, and you can compare your results with me. I'm sorry, not the conditional, I'll write the converse. So take some time to do that if you need to. I'm going to read my sentence. It says, if the area of the shape is b times h, then the shape is a rectangle. I changed this sentence a little bit just to make more sense with this situation. I'm not going to write if the area of a shape is b times h, then a shape is a rectangle. So when you're writing sentences, just make sure that they have still a correct sentence structure, and it's not just like literally copying and pasting. So then we need to think about, okay, well, if I have any shape here with an area of b times h, is there only shape going to be a rectangle that has b times h? No. Another shape that you can get is a parallelogram. And that, I think it came from the red toolkit. I'm not exactly sure which toolkit we wrote it on, what color it was, but b times h will still give you area. So although it is true for a rectangle, it's not true for only rectangles. So this is not true. It is false because it could be a parallelogram. So now we're going to turn to the back. And we're going to kind of just wrap things up together and look at just like how we look at this generally and how we write our own sentences. So number one, it says write the converse of the conditional statement below. Then assuming the original statement is true, decide if the converse must be true or not. If it is false, give a counterexample. And a counterexample is just to show like this is why, an example of why it's not true. So we're going to assume that if Bob is a beagle, then he is a dog. And then we are going to write the sentence as the converse. This is where like sentence structure is really important, because if I'm writing this sentence switch as the converse, I'm going to write this in red if I can find red on here. I'm not going to write it as if he is a dog, then Bob is a beagle. Yes, that would be exactly copying things, but we need a subject. So instead of saying if he is a dog, we're going to say if Bob is a dog first. So you really want to make sure, again, like even if you just like start by writing the sentence and you're like, oh, just kidding, like that's not going to make sense. You can erase pieces and fix it to make it make sense as a sentence. But here we need it to sound or to have a subject first. So if Bob, and then start doing the pink part, that is the second part. So if Bob is a dog. So obviously we wouldn't put if Bob, he is a dog. So we're just switching that. Then, and if you write Bob again, it's not great, but it'll still work. It'll still get to a point as long as you're still talking about Bob in the beginning. But I would say then he is a beagle. The point here is just to get the correct information out while still writing an appropriate English sentence. So now that we think about this, if Bob is a dog, is he always going to be a beagle? No. Another option for a dog would be a golden retriever. Sorry, it took me a second there. Any kind of other dog, like literally a million options. So whatever you want to write there. So this closure, take a second to write that, I guess. So in the closure, I'm going to just give you like a very quick, like upfront, this is what's up, okay? Like conditional, boom, converse, boom, done. So we're going to write conditional is if A, then B, like very upfront, okay? Converse. If B, then A. You're just switching things. And then we're going to say, just a little star here, a conditional can be true, but that doesn't mean it's converse. Has to be true. So just because the first sentence is true doesn't mean if you switch it that sentence also has to be true. I'd like you to take some time on number 2 to write your own conditional statement in its converse. And normally I would give extra credit for this in class, but since I'm not there, if you would like to show it to me when I get back next week, that's totally fine. If you feel like it's really funny, obviously school appropriate is important, but I really enjoy writing conditionals and converses in class and having this activity. So I'm bummed I can't be there for that. But also you've got some homework for tonight. Make sure you're using the answer key because I won't be able to go over it with you. So be sure to check that out. And definitely go to Math Help if you need anything.